Newton universal statement that explain Newton law of gravitation, discuss the gravitation force in manual force statement. The states that the gravitational force of attraction between two objects is inversely directly proportional to the product of their mass and inversely proportional square of the distance between the centers. States states that the gravitational force of attraction between two objects is directly proportional to the state of mass and inversely proportional to the square of the distance between its centers. Explain Newton's law of universal gravitation is a revolutionized physical understanding, providing a mathematical framework for celestial bodies such as planets, moons, stars. The study of gravitation laid a groundwork for classical mechanical explaining the various natural phenomena like moons and stars, moon tides, and planet orbits. It states that the gravitational force between two objects. It states that the gravitational force of attraction between two objects in the universe is directly proportional to the state of the mass and inversely proportional to the square of the distance between their centers. Explaining Newton's law of gravitation, universal revolutionized physical understanding of providing a mathematical frame for celestial bodies such as planets, stars, moons, stars. The study of gravitation laid the groundwork for classical mechanics explaining the various natural phenomena like moon tides and planet orbits. It states that the gravitational force of attraction between two objects states that gravitational field of attraction states that gravitational field, i.e. the field of attraction, divine between two objects of the universe, is directly proportional to the directly proportional to state of a mass and inversely proportional to the inversely proportional to the square of distance. DSEA distance between their center centers between their centers. If there is a gravity for the attraction between two objects, they are proportional to the If there is a gravitation force of attraction between two objects in object is there if there is a gravitation force of attraction between two objects is directly proportional to the mass and inversely proportional to it states that the gravitation force of attraction between two objects in the universe is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. It states that the gravitation force of attraction between two objects states that the gravitation force of attraction between two objects is directly proportional to the state of their masses and inversely proportional to the square of the distance between their centers. Newton's law of universal gravitation revolutionized the physical understanding, providing a mathematical framework for celestial bodies such as planet, moon, stars. Newton's law of universal gravitation revolutionized physical understanding, providing a mathematical groundwork for celestial bodies such as planet, moon, stars. Newton's law of universal gravitation revolutionized physical understanding, providing a mathematical framework for celestial bodies such as planet, moon, stars. The study of gravitation laid a groundwork for Newton's law of universal gravitation revolutionized physical understanding, providing a mathematical framework for celestial bodies such as planets, moon, stars. Newton's law of universal gravitation revolutionized Newton's law of universal gravitation revolutionized physical understanding, providing a mathematical framework for celestial bodies such as planets, moon, stars. The study of the gravitation laid a groundwork for classical mechanics. The study of gravitation laid a groundwork for classical mechanics, explaining various phenomena like moon tides and planet orbit. Explanation. Newton's law of universal gravitation. Newton's law of universal gravitation revolutionized physical understanding. Physical understanding physical understanding, providing a mathematical framework, framework mathematical framework for celestial bodies. See list bodies such as planets, moons and planets. ठीक है. It also laid groundwork for classical mechanics explaining various phenomena such as moon tides, planet orbit, planet orbit, orbit. Stereo gravitation laid like groundwork. Newton law of universal gravitation. Newton law of universal gravitation remains the fundamental principle in physics and astronomy. Refining the Einstein general relative. Newton law of universal gravitation remains the fundamental principle in physics and astronomy. Newton law of universal gravitation revolutionized physical understanding, providing a mathematical framework for celestial bodies such as planets and stars. The study of gravitation laid the groundwork for classical mechanics, explaining the various phenomena such as moon tides and planet orbit. Newton law of universal gravitation remains the fundamental principle of physics and astronomy, defining the Einstein general relative and remaining the cornerstone of understanding the universe motion, and remaining the cornerstone for understanding universe. Newton law of universal gravitation remains the fundamental principle in physics and astronomy. Newton law of universal gravitation remains the fundamental principle. Newton law of universal gravitation remains the fundamental principle in physics and astronomy. Newton law of universal gravitation remains the fundamental principle in physics and astronomy, refined by Einstein general relative, and remain a cornerstone for understanding. Newton law of universal gravitation remains the fundamental principle in physics and astronomy. Newton law of universal gravitation is a fundamental principle in physics and astronomy. Newton law of universal gravitation remains the fundamental principle Newton's law of universal gravity remains the fundamental principle for physics as defined by Einstein. General relativity and remain the cornerstone of understanding the universe motion. Newton law of gravitation gravitation remains Newton law of gravitation remains the fundamental fundamental principle for Newton law of universal gravitation remains the fundamental principle for universal gravitation and fundamental principle for physics and astronomy. Defined by Einstein general relativity, and remain the cornerstone is cornerstone of our understanding of the universe, universe motion. Derivation of gravitation force. Derivation of gravitation force to consider two physical spherical bodies of mass m1 and m2 separated by distance r. Consider two bodies m1 and m2 separated by distance r as shown above. By defining the Newton law of universal gravitation, the force of gravity GFG. Consider derivation, the gravitation force. Derivation of consider two phenomenal body m1 and m2 separated by the distance r. By definition, Newton law of universal gravitation force. The force of gravity Fg is G proportional to m1 and m2, G proportional to 1 by r square. Combining both together relation, we get Fg gravitation universal. The force of gravity proportional to mass m1, mass m2, distance square. Force of gravity is equal to universal constant gravitation m1 and m2 distance square. G, the value of G is universal constant gravitation. Its value is 6.673 multiplied by 10 to the power minus 11 nm square kg negative square. Yep. statement. It states that the gravitation force of attraction between two objects is directly proportional to the state of is directly proportional to the product of their masses and inversely proportional to the square of the distance between their center. Explanation: Newton's law of universal gravitation is the revolutionary physical understanding, providing a mathematical framework for celestial bodies such as planets, moon stars, and moon stars. The study of gravitation laid the groundwork for classical physics. The study of gravitation laid the groundwork The study of gravitation laid the groundwork for celestial bodies mechanics, explaining various natural phenomena like the moon and planets' orbit. Newton's law of universal gravitation remains the fundamental principle in physical astronomy, defining the Einstein general relativity remaining the cornerstone for understanding universal motion. Derivation of gravitation force. Consider two bodies M1 and M2 separated by distance r by Newton's law of universal gravitation. The force of gravity Fg is equal M1 and M2 by r square, proportional to Fg is equal to proportional M1 and M2. Fg proportional to 1 by r square. Fg proportional to M1 M2 r square. Fg is equal to universal constant gravitation, mass M1, mass M2, distance r square. Here G is universal constant gravitation. Its value is 6.673 multiplied by 10 power 11 negative 11 nm square kg negative square. Derivation. Consider two bodies and derivation of gravitation force. Derivation of gravitational force. Consider masses M1 and M2 separated separated by I don't know. Consider man M1 and M2 separated by distance r. By definition of Newton. Newton law of universal gravitation. The force of gravity. Force of gravity. Gravity. Fg is Fg proportional to M1 M2. Fg is equal to 1 by r square. Combination of both, we get F G is equal M1 M2 R square F G is equal to universal constant rotation M1 M2 R square. Here G is universal constant gravitation. .673 multiplied by 10 power 11 and square kgs. Kg of the negative square. Okay, M1 M2 F FD or FGFH FG R square G. Okay, अभी प्रूफ करना है G is equal F G R square M1 M2 unit of G N square kg kg negative square base unit of G base unit of universal constant gravitation kg ms square ms square m square kg square kg m s square m की वैल्यू 3 है 3 kg 1 m l t dimensions of G. The gravitational force is always attracted and doesn't depend upon the medium between mass. Always attracted and doesn't depend upon the medium of mass. The force is manual, i.e., it is upon a medium between masses, medium between masses. Force is always attractive and doesn't depend upon the medium between masses, medium between masses. Medium between masses, the gravitation force is always attractive and doesn't depend upon the medium between masses. Gravitation force is always attractive and doesn't depend upon the medium between masses. The gravitation force is inverse square force. It decreased by a factor of 4. Gravitation always attracted. Gravity force is always attracted. Doesn't depend upon the medium between the masses. Gravitation force is always attractive and doesn't depend upon the medium between masses. Gravitation force is always attractive and doesn't depend upon the medium between masses. Gravitation force is always attractive and doesn't depend upon the medium between masses. Gravitation force, the gravitation force is always attractive and doesn't depend upon the medium between masses. What's up? Doesn't depend upon the medium between masses. Force always depend upon the medium between masses. For the inverse square force is an inverse square. It decreases by the factor of 4 when the distance increases by factor of 2. It decreases by the factor of 9 and the distance increases by factor of 3 and so on. Force is always attractive and doesn't depend upon the medium of the masses. The gravitation force is always attractive and doesn't depend upon the medium of the masses. The gravitation force is always attractive and doesn't depend upon the medium between masses. And doesn't depend on the medium between masses. The gravitation force is always attractive and doesn't depend upon a medium between the masses. The gravitation force is inverse square force. It decreases by the factor of 4 when the distance increases by factor of 2. It decreases by I'll do that right away. Gravitational force is always attractive. Attractive and it doesn't depend upon medium between its method. The method. The gravity. There you have 4 layers. The gravitational force, the gravitational force is inverse square. Force is an inverse square. Inverse square force and it doesn't depend upon decreases by the factor by a factor factor of 4 WHE, and when the distance distance increased by a factor 2 INCRE increased by a factor 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 of 2. If DECREAS decreases by factor of 9 by a factor of 9 when the distance increases by factor of 2, then the gravitation force inverse square 4, it decreases by a factor of 4 when the distance increases by a factor of 2, it decreases by a factor of 9 when the distance is inverse for it when it decreases by factor of the distance increases by factor of 2, it decreases by factor of 4, it decreases by factor of 9 when the distance increases by when the distance increases by factor of 3 by a factor of 3, and so on. Graph is a plot magnitude. Graph is a plot magnitude and magnitude of a gravitation force, magnitude of a gravitational force as a function of the distance between two objects. It decreases by factor 4, the distance increases by factor of 2, it increases by factor of 9, it decreases by factor of 9, it increases by factor of 3, the distance increases by factor of 3, and so on. Graph is plotted the plot of the magnitude of gravitational force as the function of the distance between two objects, as the function of 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 distance, as the function of distance between two objects, 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 as the function of distance between two objects. gravitation force is over the critical upon the median of the masses. The gravitation force is inverse square force, inverse square force, and it decreases by factor of 4 when the distance increases by factor of 2. It increases the factor of 9 and decreases factor of 9 and increases distance by factor of 3, and so on. The graph is plotted the magnitude of the gravitational force as function of the distance between two objects. The graph is plotted of the magnitude of the magnitude the graph is plotted. The graph is plotted in the plot of a magnitude. The magnitude of the gravitation force is a function of the distance between the object. The graph is a plot. The graph is a plot of the magnitude. The graph is a plot of 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 magnitude. The graph is 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 plot of magnitude of gravitation. Plot of magnitude of the gravitational force as a function of the distance between two objects. The gravitational force is the inverse force. The gravitation force is decreased by a factor of 4. The gravitation force is decreased by a factor of 4. The gravitational force is decreased by a factor of 4. The gravitational force is decreased. The gravitational force is decreased by a factor of 4. The gravitational force is decreased by a factor of 4. The gravitation inverse square force is decreases by factor of 4. Distance increases by factor of 2. It decreases by factor of 9 and and distance increases by factor of 3, and so on. The graph is plotted of the magnitude of gravitational force as a function of distance between two objects. The graph is always the graph is the gravitational force. Gravitational force, F-O-R-C-E, force is always attractive and doesn't depend upon medium between its masses between the masses. Between the masses आगे जाते हैं. Gravitational is I don't know. Gravitation is inverse force. Gravitation force is inverse factor होगा. Inverse square force. Gravitation force is inverse force. It decreases decreases by factor of 4 factor of 4 and this distance increases increases by factor of 2. Okay, it decreases by factor of 9 and distance increases by factor of the distance increases by a factor of 2 of 3 so on. Factor of 9 so on, so on. The graph is plotted PL or is plotted against of the magnitude of I don't know. Magnitude of gravitational force, gravitational force between two objects. ये लिखिए gravitational force is a mutual force. The mutual gravitational for i.e. m1 exert for the mutual force gravitation for the mutual force exert gravitation for the mutual force exert gravitation for the mutual force gravitation for the mutual force exert i.e. if m1 exert gravitational force on m2, then m2 exert force on m1. Force exert on m2 by m1 is equal f21 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 force exerted m1 by m2 f12 two force is equal to the magnitude by opposite direction. The force are given. Gravitation force as manual force. Gravitational force as manual mutual as mutual force. gravitational force is a mutual force force, force, i.e. if if mass m2 exert exert force, if mass m2 exert force F1C force of gravitational force जो कि gravitational on m1 then m2 exert exert then m1 exert force on m2. Yeah. F force exerted on m1 m2 by m1 is equal F21 force exerted on m1 by m2 is equal to F12 equal to factor 2 factor have equal magnitude but opposite factor have equal equal magnitude but opposite direction, but opposite opposite direction opposite direction. You can if m2 mass m2 x on mass m1 then m1 F12 F12 F F12 mass F12 X on F21 as reaction. Here the reaction force is a reaction for the gravitation. Therefore, Newton's universal law of gravitation advocates then Newton law of universe advocate advocate Newton with third law of motion two bodies A and B are placed at a distance m1 meter 1. Okay, use the fraction blah blah blah. Radius distance r है, m1 40 kg है, m2 50 kg है, universal constant gravitation. Okay, we're gonna put on calculator. Alright, 6.67 6.673 multiplied by 10 power negative 11 multiplied by mass m1 के 45 multiplied by 50. ओके, अब नीचे जाते हैं 1 इक्वल 1 पॉइंट. यप, mass of a moon. ठीक है, distance. ओके, mass m1 ये है, m1 m2 distance. ठीक है, आसान है. Newton's law of gravitation is called universal law because it applies to every object in the universe that has mass regardless of the size and location. Newton's law of gravitation is called universal law because it applies to every object in the universe that has mass regardless of size or location. This means that every object with mass is gravitationally attracted to each other with the mass they Newton's law of Newton's law of gravitation is called universal law because it applies to every object in the universe that has mass regardless of size or location. This means that every object with a mass is gravitationally attracted to each other with a mass when their gravitation field interacts. I need water, like thirsty as fuck. Newton's law of universal gravitation is called universal law because it applies to every object in the unit that has mass regardless of size or shape. Newton's law of gravitation is called Newton's law of gravitation is called universal law because it applies applies to every object in the universe regardless that has mass regardless of size or location, size or location, full stop. Oh. Size or location. इतना काफी I don't know. More. Size or location. This means that gravity, every object with a mass, every object with a mass attracted to each other object with the mass when their gravity field and their gravitational field reacts. इंटरैक्ट होना चाहिए तो रिएक्ट और इंटरैक्ट ओके gravitational field strength. होगा define the gravitational field strength and how it can be calculated. Gravitational field, the space or region around the mass object like Earth and Sun, etc., in which gravitational field acts on a body is known as gravitational field. Gravity has the space or region around the mass object like Earth and Sun. Earth and Sun is known in which gravitational field acts on other bodies known as gravitational field. The space around the region of massive object around a massive object like Earth and Sun which have in which it gravitational force act on other bodies is known as gravitation field. The space or region around the space in which its gravitational force act on other bodies known as gravitational field. Gravitational field is represented by gravitational field lines that indicate the direction and strength of gravity. The space of gravitation. The space of gravitation and region. Okay, I'm taking a break. Just like that, and there you go. The gravitation, the space or region around the map. The space or region of around a mass object like Sun Earth in which gravitational force act on other bodies is known as gravitational field. Gravitational field is represented by gravitational field lines that indicate the direction of the strength of gravity. The space or region around the massive object like Earth and Sun is which its gravitational force act on other bodies is known as gravitational field. Gravitational field is represented by gravitational field line that indicate the direction and strength of gravity. Strength of gravity. Closer gravitational field line represent the stronger field. Further gravitation line indicate weaker field. Gravitational force is an interaction between the test mass. Critical the space or region around the mass object like star, Earth and star, etc., in which gravitational force act on other bodies known as gravitational field. The space or region around the massive object like the space or region around the massive object like Earth and Sun is which its gravitational force act on other bodies is known as gravitational field. Gravitational field is represented by gravitational field line that indicate the direction and strength of gravity. Gravitational and strength of gravity indicate the strength. The space or region around the mass object like Earth and Sun in which gravitational force act on other bodies is known as gravitational field. Gravitational field is represented by gravitational field lines that indicate the direction and strength of gravity. The closer the gravity, the closer the line, the stronger the field. The further the line, the weaker the field. Gravitational field force is an interaction between a mass test and gravitation field creates a source of mass. And gravitation field creates a source of mass. The gravitational force indicates gravitational force is an interaction between mass test. Gravitational force is the interaction between mass and the gravitational field created by mass. Is a interaction between a source of mass and the gravitational field is created by source of mass. Gravitational field. Gravitational field. FIELD field. Space or mass. Space or region. The space or region massive object of massive object like like Earth and Sun is which its gravitational force, its gravitational force act on other bodies is known as gravitational field. Gravitational field. Gravitational field is represented by gravitational field line that indicates the direction and strength strength of the line of gravity. Closer gravitational field line. Closer gravitational field line, the further the stronger field. The further further the field, the weaker the further the field line, the weaker the field, full stop. Weaker the field. आगे क्या मसली बताया? I don't know. Again, book. The weaker the field, gravitational force, gravitational force interact with gravitation field strength. Interacts with test mass and gravitation field created by the source of mass. Source of masses. तो यहाँ तक ही according to AWCORBIG according to Newton second law. Second law, A is equal F by M. Similarly, AG is equal FG by M. Gravitational field strength, gravitational field strength. Gravitational field strength is the force of gravity experienced by per unit mass. Gravitational field strength. Gravitational field strength is the gravity of force of gravity. The force of gravity experienced by gravitational field strength is the force of gravity experienced by unit mass at specific point in a gravitational field. Gravitational field strength is the force of gravity experienced by per unit mass. Gravitational field is the source of gravity. The gravitational field strength is the force of gravity experienced by per unit mass at specific point in gravitational field. Specific point in gravitational field. Gravitational field strength is the gravitational field strength is the force of gravity. Gravitational field strength is the force of gravity. The gravitational field strength is the force of gravity experienced by mass per unit mass at a specific point of gravity. Gravitational field strength G is equal to Fg by M. Equation 1. Kiss my ass. Gravitational field strength is the force of gravity experienced as mass per unit mass. Gravitational field strength is a force per unit mass per unit. Gravitational field strength is a force of gravity experienced by per unit mass in specific at a specific point of gravity. Gravitational field strength is the force of gravity experienced per unit mass at a specific point per unit mass at specific point per unit mass at specific point per unit mass. Gravitational field strength gravitational force is the force of gravity at experienced per unit mass at specific time of in a gravitational field. Gravitational field strength is the force of gravity experienced by the force of gravity. Gravitational field strength is the force of gravity. Gravitational field strength is the force of gravity. Gravitational field strength is the force of gravity. The gravitational field strength is a force of gravity that is experienced per unit area per unit area per unit area per unit mass in a specific point of gravitational field. Gravitational field strength. Gravitational field strength strength. Gravitational field strength आगे क्या आता है? I don't know. Gravitational field strength the field F-I-E-L-E field strength S-T-R-E-N-G-T strength is a force of gravity gravity experience experience by per unit mass per unit mass gravitation is per unit mass experience per unit mass I don't know experience but in specific point of gravitational field gravitational F-I-E-L-D field आगे कहते हैं इसके यूनिवर्सल कांस्टेंट gravitational field is equal to F force gravity by M equation 1 gravitational force exerted by mass m on m at a distance r is given by Newton law of gravitation Fg is equal okay guess my ass yeah I know Newton law of gravitational force of by gravitational force exerted by mass on a m is at a distance r is given by Newton law of gravitation force exerted by mass m on m at a distance r is given by Newton law of gravitation the gravitational force exerted by mass m on m by distance at distance r is given by Newton law of gravitation gravitational force by mass m on m at distance r is given by Newton law of gravitation Fg is equal to gm by r square putting Fg in equation from equation 2 in equation 1 we get g is equal the universal constant gravitation mass by m by r square 1 by m से कट जाएगा equation थी g is equal universal constant gravitation mass m universal constant gravitation of mass by radius square equation 3 gravitational field strength depend upon the mass source distance of the point of mass source gravitational field strength depend upon the source mass and distance of source mass distance of point of from source map. Unit of gravitational fields and G is equal G by M n by kg ms square kg ms square. Okay. Is a vector of the magnitude. Gravitational field strength is a vector of the magnitude. Gravitational field strength is the vector of magnitude of G pointing the direction of the gravitational force. For exerted by mass and at a point at distance r is a given gravitational force exerted by mass m on a m. Gravitational force exerted by mass m on a m at a distance r is given by Newton's law of gravitation. Newton's law of gravitation. Force exerted by mass m on m at a distance r is given by Newton's law of gravitation. Newton's law of gravitation. Gravitational force by a mass m on m at distance r is given by Newton's law of gravitation. Fg is equal G, a universal constant gravitation force G, gravitation force m, okay, by a distance square. Equation 2, putting equation 2 in equation 1 we get gravitational field strength is equal to G by m r square. G by m G, universal constant gravitation, mass m, distance square, whole bracket by 1 by m cuts हो जाते हैं. Gravitational field strength G by m by r square. Equation 3. Gravitational field strength depends upon source mass source distance of a point from source mass from source mass. Right. Gravitational field strength is the unit of gravitational field strength. G is equal to n by kg f G by m fuck. Congratulations. This happens every day. Okay. The value of G blah blah blah. Gravitation and rotation. Gravitation field strength is a force gravity experienced by pressure and mass at a specific point of gravity. Given gravitational force, gravitational force exert exert on mass m of m at distance ST distance r square. Given in universal U and I universal gravitational law. Okay. F G is equal to G M R square. Equation 2. What equation? What? Yeah, small shit. What? EQ 2 in EQ 1 B. Yeah. G equal G M R square whole bracket 1 N से कट गया then G is equal G M R square. Equation 3. Okay. Equation 3. Equation 3. Equation 3 here again. Unit of gravitation fuel strength fuel strength STREN medium strength some mass distance of point from source mass source mass unit of yield depend what unit of yield equal F G is equal F G by G is equal ठीक है अब यहाँ लिखते हैं is equal N by M is equal kg ms square kg कर देते हैं is equal ms square ठीक है नेगेटिव gravitation free strength is a vector of the magnitude g the gravitation gravitational field strength is a vector of the magnitude STRENG is a vector of a magnitude g magnitude of g pointing in the direction of the gravitation force. Gravitation free strength is a factor in magnitude of g in direction pointing in the direction of gravitational force. Gravitational force Gravitational field strength. Gravitational field strength is a vector of magnitude, a vector with a magnitude g pointing in the direction of gravitational field. Gravitational force. Gravitational field strength. Gravitational field strength strength. Gravitational field strength is numerically equal to acceleration equal to acceleration due to gravity. Yeah, that's good. Okay, gravitational field. P M F. Gravitational field strength is a vector of the magnitude with a magnitude g pointing in the direction of gravitational field strength. Gravitational field strength is numerically equal to the acceleration due to gravity. Numerically equal. Gravitational field strength is equal to the magnitude. Gravitational field strength is equal is a vector with a magnitude g pointing in the direction of gravitational force pointing in the direction of gravitational force pointing in the direction of gravitational force pointing in the direction of gravitation. Gravitational field strength is a vector with a magnitude of g pointing in the direction of magnitude pointing in the direction of our gravitational force pointing in the direction of the field strength is equal to the magnitude is equal to the gravitational field strength is equal to the field strength is equal to the magnitude of g pointing in the direction of gravitational force pointing in the direction of magnitude. Gravitational field strength is equal to the vector equal to the magnitude. Gravitational field strength is equal to the factor of the magnitude g and it's pointing in the direction of gravitational force. Gravitational field strength is numerically equal to the acceleration due to gravity. Yeah, it makes sense. Numerically equal to the acceleration due to gravity. Okay. Gravitational field strength is a vector with a magnitude of g pointing in the direction of gravitational force. Gravitational field strength is equal to the numerically equal to the acceleration due to gravity. Okay. The value of g on the surface of Earth. Yes. I want to fucking put my hair. Newton apply the Newton law of gravitation to derive an expression to calculate the value of g on the surface of Earth. Newton law of universal gravitation shows the value of g depend upon the mass, distance. Newton law of universal gravitation. Newton law of universal gravitation shows the value of g depends upon the mass, distance. Newton law of universal gravitation. 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 Newton law of universal gravitation depends upon the Newton law of universal gravitation shows the value of g to depend upon the mass of a distance. Mass and distance. Let us consider the small stone of mass mo, of mass mo, of mass mo, small stone of mass mo, for mass mo. Newton law of universal gravitation shows the value of g depend upon mass and distance. Let us consider small stone mass mo placed on a surface of Earth. Look at that. Got some fucking more. Yeah. Give me a pointer. Apply Newton law of gravitation. Gravitation to drive an expression to calculate value of g on surface of Earth. Surface of Earth. Newton law of universal gravitation. Newton law of universal gravitation depends shows the value that the value of g depends upon distance, on mass and distance, mass and distance. The law of universal gravitation shows that the value of g depends upon the mass and distance. Let us consider a small stone mass. Let us consider small stone mass m placed on a circular on surface of Earth. The surface of Earth. Mass of Earth. Mass of Earth. Mass of Earth is equal m e radius of Earth re. Newton's law of universal gravitation. Newton's law of universal gravitation shows the value of g depend upon the distance, depend upon mass and distance. Let us consider a small stone of mass m placed on the surface of Earth. Mass of Earth m e, radius of Earth r e. As the radius of a stone is very small as compared to the radius of Earth, a small radius of a stone is as compared to Earth. Consider a small stone of a mass mo placed on the surface of Earth. Mass of Earth mass of Earth e, radius of Earth r e. As the radius of a stone is very small as compared to the radius of Earth. As radius of a stone as radius r a d I use radius of stone is very small of stone is very small as stone of radius is very small as compared to a stone of radius is very small as compared compare to radius of Earth to radius of Earth. Therefore it is ignored and Earth is ignored between center of the Earth and distance distance between Earth between center of Earth CENTRE center of Earth and stone is approximately 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 equal to the radius of Earth. Equal to US radius of Earth. Newton law of universal gravitation. Newton law of universal gravitation shows the value of G depends upon mass and distance. Let us consider a small store of a mass mo on the surface of Earth. Let us consider a small stone mass mo on the surface of Earth. Mass of Earth me, mass of radius of Earth re, as a radius of stone is very small as compared to radius of Earth. Therefore, it is ignored and the distance between the center of the Earth and stone is approximately equal to the radius of Earth. Therefore, it is ignored and distance between the center of Earth and stone is approximately radius of Earth. Therefore, it is ignored and the distance between the center of Earth and stone is approximately therefore it is ignored and the distance between the center of Earth and stone is approximately equal to the Earth. Therefore, it is ignored and the distance between the center of Earth and stone is approximately equal to the radius. As the radius of stone is very small as compared to radius of Earth, therefore it is ignored and the distance between center of the Earth and stone is approximately equal to the radius of Earth. समझ आ गया? Radius of Earth. According to Newton's law of universal gravitation, force between radius of Earth, radius of stone is equal to the small radius a radius is a stone is very small as compared to radius of Earth. Therefore, it is ignored and the distance of center of Earth and the stone is approximately equal to the radius of Earth. Very good. According to Newton's law of universal gravitation, the gravitational force between stone and Earth is Fg is equal to constant gravitation m by stone mass small stone mass of Earth by radius square. Earth square equation 1. The gravitational force is also equal to the weight of the body. Weight of a body is equal to mass of small stone g. Gravitation field strength. Comparing equation 1 and 2, we get gravitation small stone of mass gravitational field strength is equal to universal constant gravitation mass small stone mass of Earth radius square. Gravitational field strength is equal to universal constant gravitation mass of Earth radius square. Equation 3. Okay. What the fuck this supposed to do? It's fucking long, huh? Oh shit. joke me, you know. I literally wanna fucking sleep. Now universal gravitation show the value of G, the value of G, the value of G, gravitation show the value of G, that value of G depends on the mass and the distance. The Newton law of universal gravitation shows that the value of G depends upon the masses and distance. Let us consider a small stone of a mass m placed on a surface of Earth. Let us consider a small stone of a mass m placed on the Earth's surface. Mass of Earth m e, radius of Earth. Its stone is very small as compared to radius. Small stone is very small compared to radius. Therefore, it is ignored, and the distance between center of the Earth and the small stone is approximately equal to the radius of Earth. According to Newton's law of universal gravitation, the gravitational force between a stone and the Earth is Fg is equal Gm, general constant gravitation, mass of a stone, mass of Earth, radius square. Equation 1. The gravitation force is equal to the weight of a body. Okay, Fg is equal W is equal MOG. Comparing equation 2 and 1 and 2, we get MOG is equal to MO mass of Earth radius square. MO कट जाता है, ठीक है. G is equal mass of Earth radius square. Equation 3, ठीक है. Equation 3 shows the value of G. The equation 3 shows the value of G. Equation 3 shows the value of G. Value of G that doesn't depend upon the mass of body. This means that the light and heavy body should fall at same rate. This means that the light and heavy body should fall. Understand? Shows the value of G doesn't depend upon the mass MO of body, MO of the body, MO of the body. The body, MO of Equation 3 shows that the value of G doesn't depend upon the mass MO of the body. This means that the light and heavy body shouldn't fall at same rate. This means that the light and heavy body shouldn't fall on the same rate. Shouldn't fall at the same rate. This equation shows that the gravitational field can depend only on the mass of the Earth M(E) and the radius of Earth R(E). This shows that equation 3 shows that the value of G doesn't depend upon the mass of the body. It depends between the heavy and light body should fall at the same rate. The equation shows that the gravitational field can depend only upon mass of the Earth and the radius of Earth. Doesn't depend upon the mass of the body. Doesn't depend on mass of body. This means that light and heavy body should follow the same. The equation shows that the gravitation field can depend on mass of the Earth, radius of Earth. Mass of Earth, radius of Earth. Therefore, doesn't depend upon MO of the earth, MO of the earth, not MO of earth of the body. Which means that light and how they should fall, SHOULD, should fall, FALL, fall at same rate, ठीक है, at same rate, this equation also shows equation shows that it only depends on I don't know. It only depends on mass of earth and radius of earth. I wanna take fucking dirty out. Proper dirty. Mass of earth, radius of earth. Again, for earth. For earth, we know that mass of earth ME is 6 multiplied by 1024 kilograms and 6 radius of earth millimeter kg. I want to take a dump. What can I say? It's hard. For Earth, we know that the mass of the Earth is 6 multiplied by 10 power 24 and radius of Earth is 6.4 multiplied by 10 power 6 m. Okay, the mass of the planet and the radius is significantly influenced by the G and or weight and other Alright, the variations of G with its altitudes. When the weight from the surface of Earth is increased, then the value of G also and our weight decreases. When the surface when height from the surface of the Earth increases, then the value of G of and our weight decreases. The value of G and height H. When the height of the surface of Earth, when height from the surface of the Earth increases, when the height of the surface of Earth increases. When the height of the surface of Earth increases. When the height of the surface of the Earth increases, when the height of the surface of Earth increases, when height of the surface of Earth increases, When height of surface of Earth increases, then the value of g and our weight decreases. Then our weight decreases. When value of g and our weight decreases, the value of g at height h from the Earth's surface is given in the equation gh is equal to universal constant gravitation mass of Earth radius plus height square. Equation 1 as we know. When the height from the surface of Earth increases, then the value of g and our weight decreases. The value of g and height h from the Earth's surface given by the equation gh is equal to universal gravitation mass of the Earth radius plus h whole square. Equation 1. As we know that g is equal to universal constant gravitation mass of the Earth radius of Earth square, and g universal constant gravitation mass of the Earth is equal to g r square, g r radius square, and universal constant gravitation mass of Earth is equal to gravity radius of Earth square. Equation 2, putting g universal constant gravitation mass of Earth from equation 2 in equation 1, we get g h is equal g radius of Earth square by radius of Earth plus height square. Equation 3. The value of when the height from the surface of Earth increases, then the value of g of our weight decreases. When the value of g at the height from the Earth's surface is given equation from the surface of Earth is increased. When the value of g decreases and our weight decreases, the value of g and the height from the surface of Earth's surface is given by the equation gh is equal to g universal constant gravitation mass of Earth by radius plus h radius of Earth plus height whole square. As we know, g is equal universal constant gravitation mass of Earth by radius square. Universal constant gravitation mass of Earth is equal to g gravity radius of Earth square. Equation 2, put equation universal constant gravitation mass of Earth from equation 2 in equation 1, we get gh is equal to g radius of Earth square by radius of Earth plus h height whole square. Equation 3. This equation shows that as we further go away from the Earth's surface, go away from the center or the surface of Earth, the height increases and the value of demonstrator in equation 3 increases. Therefore, the value of g decreases. This shows that the equation This equation shows that the value of this equation shows that as we go further away from the center of Earth, height increases and the value denominator the value denominator in equation 3 also increases. therefore the value of G decreases. This equation shows that the as we go away from the center or further or center or surface the height increases and the value of denominator in equation 3 also increases, therefore the value of G decreases. This equation shows that as we go further away from center or Earth's surface, the value of H increases and the denominator of equation 3 also increases. Therefore, the value of G decreases. Okay. And from equation 3, if the height is very small, i.e. only few meters, then there is no change in the value of G. If the height is so small, i.e. only few meters, then there is no This equation shows that as we go further from the Earth, as we go further away from center or surface of Earth, the value of height increases and the denominator in equation 3 also increases, therefore the value of G decreases. Okay, in equation 3, if the value of height is very small, i.e. only few meters, then there is no change in the value of G. Then there is no change in the value of G. The change in G only is noticeable when we are at very long distance. When we are in very long distance. As an expression to calculate the value of G. Calculate the value of G. The value of G from center of the Earth at height above Earth's surface. When the height is the height from surface of Earth surface of Earth increases, INCREAS increases, then the value of G and R WEIGHT weight increases, R decreases, DECR decreases, the value of G and H height from the Earth's surface is given from okay. GH is equal to universal constant rotation mass of Earth, radius of Earth plus h square. Equation 1, as we know G is equal to universal constant Earth radius square. Therefore, okay, GME is equal to radius of Earth G radius of Earth square. Equation 2, DUT EQ to put GME of UQ 2 in 1, we get GH is equal to GRE square by radius of Earth plus height square. Equation 3 shows that this equation shows that this equation shows that as we go further, FUR further away from Earth, from center or surface of Earth, the height h increases and denominator of G denominator of equation 3 increases, therefore the value of G increases. Of G increases. Okay. यहाँ क्या आता है? Value of G doesn't no if height is very small, if height is very small, i.e. I dot e only few meter, then the value of G doesn't increase. Few meter, then the value of G doesn't change. Hey! Okay, you know it. Oh, smell that shit. The change in G is only noticeable at very long distance. Indicate suitable. Fuck it, यार मैं दिमाग खराब हो रहा है. Altitude L E U altitude G H M S square. Okay. 9.8 radius of Earth, average radius of Earth, radius, Mount Everest, Mount Everest. One more example, 36 6.6, 9.7, 9.7. Highest managed balloon. Balloon. Gosh. Gravitation field line. Alright, let's do this shit. Gravitation field lines are visible, representing in gravitational field surrounding the heavy mass that indicate the direction and the strength of the gravitation field line. Gravitation field line are visible. Gravitation पूरा लिखते हैं, पहले सही नहीं आता था. Gravitation field line is only visible, representing only satellite speed star लगा हुआ geometrical satellite. Gravitation field lines are representative of the gravitational field surrounded the heavy mass that indicate the direction and the strength of the gravity force. These lines always directed towards the direction center of mass. Gravitation field lines are visible representation of gravitation field. Gravitation field line are a visible representation of gravitation field surrounded heavy mass that indicate the direction and strength of the gravitational force. The gravitation field are visible representational. Gravitation field are visible representation of gravitational field. Gravitational field surrounded is a visible representation of gravitational field surrounded with a heavy mass that indicate the direction and strength of the gravitational force. These lines always indicate the direction towards the center of the mass. The direction. Gravitation field lines are representational of gravitational field surrounding the heavy mass that indicate the direction and strength of the gravitation force. Gravitation field lines are visible of a gravitation field surrounded with gravitation field lines. Gravitation field lines are visible representing of the gravitation field surrounding heavy mass that indicate the direction and strength of the gravitation force. These lines are always directed toward the center of the mass. Gravitation field line. Gravitation field lines are visible virtually representing the gravitational field strength surrounded the heavy mass that initiate the direction and the strength of gravitation force. These lines are always directed towards the center of the earth, center of the mass. Gravitation field line. No phối line. Gravitational field lines are visible. And field lines are visible. ARER visible. VISUA visible. A virtual representation of gravitation lines field surrounding FIELD field surrounding 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 the heavy mass that indicates in DICAT indicate the direction and strength, direction and strength of gravitation force. These lines are always directed towards the center of mass. Directed towards center of mass. There will be a line of visible and representation of gravitational field on a heavy mass that indicate the direction and strength of gravitation force. These lines are always directed towards the center of mass. Few lines are visible. Virtual representation of gravitation field. Virtual representation of gravitation field or gravitational line are virtual representation of gravitational field surrounding the heavy mass that indicate the direction and strength of gravitation. So these lines are directed towards the center of mass. Directed towards center of mass. These gravitational field are virtual representation of gravitation fields surrounding heavy mass that indicate the direction and strength of gravitation force. These lines always indicate towards center of mass. This path along which the test mass falls freely towards the mass, such as Earth. This path along the test mass falls freely towards the heavy mass. Gravitation and always are virtual representation of gravitational field surrounding the heavy mass that indicate the direction and strength of gravitation force. These are always directed towards the center of mass. They are virtual representation of gravitational field surrounding heavy mass that indicate the direction and strength of gravitation force. These lines are always directed towards the center of mass. Gravitation fields are a virtual virtual representation of gravitation few surrounding heavy mass that indicate direction strength of gravitation for these line always indicate this line always directed towards the center of mass. These line always directed. These lines are always directed towards center of mass. Towards center of mass. These lines always directed 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 towards center of mass. The path along which the test masses fall free towards the heavy mass, such as Earth in its gravitational field, is called gravitational field line. The path along which the test masses fall. The path along which test masses fall. The path which along test masses fall. Path along which test masses fall freely. The path along which test masses fall freely towards the heavy mass such as Earth in its gravitational field is called gravitational field line. Gravtation path, the path along which test masses fall freely towards heavy masses such as the path along which test masses fall freely towards the heavy mass such as Earth in its gravitational field is called gravitational field line. Gravitational field line, the path along which test masses fall freely towards heavy masses such as Earth in its gravitational field is called gravitational field line. The path along which test masses fall freely towards heavy masses such as Earth in its gravitational field called gravitational field line. The path along which its masses fall freely towards heavy masses. The path along which its test masses fall freely towards heavy masses such as Earth. It is called gravitation field. In its gravitation field is known as gravitation field line. The path along which test masses fall freely towards the center towards the heavy masses such as Earth in its gravitational field is called gravitational field line. The path along which test masses fall freely towards heavy masses, heavy masses towards the heavy masses. It is in it I don't know. In it gravitational field, in it gravitational field is known as, it's called Galen, is called gravitational field cell lines and interior lines. The path along which test masses fall freely toward heavy masses like Earth is its gravitation field called gravitation field line. When a body is dropped from some height, it moves towards the Earth and the path forward by the gravitation field line. When a body drops some height, it moves towards Earth and the path follows by the gravitational field line, and the path followed by its gravitational field line. When a body is dropped from some height, it moves towards Earth and the path followed by a gravitational field line. When a body drops from height, it moves towards Earth and the path by its gravitational field line. The path along with just masses for freely towards its heavy masses like Earth. In its gravitational field, also gravitational field, like when a body drops some height, it moves towards Earth and the path by its gravitational field line. Gravitational field line. Gravitational field line. Your path along which test method for field towards heavy masses such as field called gravitation. When a body drops some height, it moves towards Earth and the path follows by its gravitation field line. When a body is dropped from some height, it moves towards Earth and path followed by gravitation field line. When a gravitation field is represented by gravitation field line. When a body drops some height, it moves towards Earth and the path followed by its gravitation field line. When a body drops height, height. When a body drops height, it moves towards Earth by path by the gravitational field gravitational fuel line by gravitational fuel line. Gravitational field line is represented by gravitational field line that indicate the direction of strength of gravity. Field is represented by gravitational line that indicate the direction and strength of gravity. Field is represented by gravitational that indicate direction. Of gravity. Closer gravitational field line represents the stronger, the further it's away. The closer gravitational field field line, the stronger the field, the further further the field line represent the weaker gravitational field, the field strength. Okay. Duty calls. Record fucking read it inside. Okay. gravity constant uniform surface consists of uniform surface maintain the constant density simplify math distribution in astrophysics and specifically calculated to generate gravitational force without considering difference in density. Outside the phase, the gravitational field acts as if all mass is concentrated at the certain, resembling that of a point of a mass with the same total mass. याद होगी बेसिक याद होगी ग्राफ बना लें ओके ओके satellites ये याद करना satellite and what does it mean by satellite, how is natural. A satellite is any object that orbits the planet due to the gravitation, due to the force of gravity, maintaining a stable path around it. A natural body orbiting a dwarf planet, mirror planet where the body is large body gravity dominates the system is called natural satellite. 6 of the major planets possess natural satellite, often termed as moon. Satellite, yes. Okay, so yes. Holy shit. A satellite is any object that orbits the planet due to the gravitational force of gravity, maintaining a stable path around it. A satellite is a satellite. Satellite is any object that revolves that orbit orbit around Earth, around the planet, orbit around the planets, planets due to force of gravity, maintaining a stable path around it. A satellite is any object that orbits the planet due to the force of gravity, maintaining a stable path around it. A satellite is any object that orbits the planet due to the force of gravity, maintaining a stable path around it. A satellite is any object that orbits around the planet due to force of gravity, maintaining a path revolving around it. Maintaining a stable path around it. Maintaining a stable path around it. Oh shit. A natural body obtained. A natural body. A satellite is an object. That obtained that orbit the planet due to force of gravity, maintaining a stable path around it. A satellite is an object that orbits the planet. A satellite is an object that orbits the planet. Due to force of gravity, due to force of gravity, due to force of gravity, due to force of gravity. आगे क्या आता है? I really don't know. Due to force of gravity, it maintains stable path around it. A natural body orbiting a planet, draft plan, mirror plan, draft plan, or mirror plan, draft plan and mirror plan, where the large body gravity dominates the system is called natural satellite. 6 of the major planets possess natural satellite, often termed as moons. A natural body orbiting a planet, a draft plan or mirror planets, a natural body orbiting a planet, draft planets or mirror planets, where a large body gravity dominates the system, where the large body is gravity dominates the system is called natural satellite. A natural body orbiting planets, a planet, draft planet or mirror planet, where a large body gravity dominates the system is called natural satellite. 6 of the major planets possess natural satellite, often termed as moon. Natural body, NATUR, natural body orbiting planet, PLAN, planets, the moon. Natural body orbiting planets, natural body orbiting planet, draft planets, PLAN, planets, and or mirror planet, where a larger body gravity where larger body gravity dominates the system. System is called I don't know. Shit. How it was. Natural satellite. SATLITE 7 planet poses, POSS, poses natural sunlight, from as moon. Artificial satellite launch in 1954, a natural place where a internationally placed in an orbit around the celestial bodies for communication, military operation, and scientific research. Artificial satellite launch in 1954, 1957, 1957, and artificial satellite launches in 1954 are internationally placed in orbit for around celestial bodies for communication, military operation, and research. ठीक है, artificial satellite artificial satellite, satellite, artificial satellite launches state satellite LAUNC launches in 1957 आगे क्या आता है? Thinking 1957 internationally orbiting orbiting around around celestial celestial bodies. Military purpose for these satellite communication military operation military operation and scientific experiments and research and discoveries. Engineer has developed various types of satellites. Each satellite serves a specific purpose or mission, orbiting Earth without engine due to Earth's gravity pull. Communication satellite. Engineer has designed specific satellite for specific purpose. Engineer engineer has developed specific artificial there are various types of satellites, various types of satellite, SATELLIT satellite for various purpose and missions. and mission M IFFION mission orbiting around Earth Earth without engine and through DHROUGH through Earth force of gravity. Communication, military, military, weather क्या कहते हैं GPS वो navigation scientific बस यही चार है scientific science SCI scientific guidelines. Okay. Communication science. अपनी तरफ से कम्युनिकेशन सैटेलाइट अभी क्या लिखा है क्वेश्चन लिखते हैं तो डायरेक्ट आंसर करते हैं सैटेलाइट एंड ऑर्बिट्स सैटेलाइट एंड ऑर्बिट SATELLITE satellites and orbit ORBITS orbits. That's our letter. Launched in 1950. This orbital around celestial body for communication, military operation and scientific research. In general, has developed various types of satellites. Each satellite serves a purpose and mission. Orbiting Earth without any engine due to Earth's gravitational pull. Communication satellites are used for long distance communication through radio frequency. Most communication satellites are geostationary, meaning they move in the same direction as the Earth rotates and remain fixed at the specific position. This allows for uninterrupted contact with ground station. Communication satellites. These satellites are used for long distance communication through radio frequency. ठीक है? Most communication satellites are geostationary, meaning that they move along the same direction as Earth rotation, alright, and remain fixed at specific position. This allows for uninterrupted contact with ground station. Weather satellite, cameras and other instruments are directed towards Earth's atmosphere. They provide several weather and great aid to weather forecasting. Navigation satellite assist in determining the position of ground-based objects like ships, spacecraft, and automobiles equipped with specific radio receiver. Air Force operator Navistar Global Positioning System is 24 satellite. It provides accurate position information ranging from 100 meter or less than centimeter. Military satellites are similar to communication satellite but They send encrypt data only specific receiver can decode it. Scientific satellite maps study the ocean and atmosphere and observe distant stars and like humble. They provide clear picture and deep space. Launching a satellite into space orbit involves a complex and careful planning process to ensure successful. Satellites are put into orbit by ablating high them high altitude and accelerate them high space. Spacecraft like rockets and as if the speed is low, the satellite will fall back to. If the speed is high, the satellite will either move in perpetual orbit or escape out of Earth's gravity, never return escape speed. However, if the speed is just adjust, it will move in a circular orbit forever. Satellites are typically put in nearly circular orbit because such orbit requires the least energy. Orbital velocity. Satellite object that orbit around planets due to maintaining stable a natural body of orbiting a planet graph planet and mirror graph and mirror planet planet graph and mirror planet आगे क्या था I don't know graph and mirror planet they are large bodies dominate the system. good enough. System body classification, military operation and system body classification. Military and research ENERGINER engineers and design Pacific various satellite SATE and satellite for various purpose and mission. Orbiting in Earth without engine to Earth gravitation gravitational pull. Communication, navigation, military or scientific. Nation. Communication satellite. Communication. Satellite. Communication satellite. Satellites are used for long range communication. communication through radio signal to the frequency FREQUENC1 signal Right. Most communication geostationary geostationary meaning they move with earth rotation and remain fixed position to get a signal. Rather, headlight headlight weather and EQ with weather भी हो गया ये भी हो गया मैंने करी तेरी लाइट recording. रिकॉर्डिंग यहाँ पे करा दी। बेहतर वाला भी हो गया, मिलिट्री भी हो गया, नेविगेशन सैटेलाइट और नेविगेशन now let's now we start give specific accurate vision game research running humble other planets running और क्या आता है स्लो अगर वो orbital velocity is the velocity with which a body revolves around the other body in circular orbit. A satellite has a constant magnitude and tangential velocity called orbital velocity. Orbital velocity is the velocity with which body revolves around the other bodies. In circular orbit, a satellite has a constant magnitude of tangential velocity called orbital velocity. चलो इंशाल्लाह कर लेंगे इसका यार showing like orbital velocity is the velocity of a body, velocity with which body revolves around. Orbital velocity is the velocity. Orbital velocity. What is orbital velocity? Orbital velocity is the velocity. Orbital velocity is the velocity. Orbital orbital velocity velocity is the velocity velocity is the orbital velocity is the velocity that which body revolves around the other body which body revolve revolve revolves around a double around around which body revolve around the other bodies other bodies body body other body. Orbital velocity is the velocity with which body revolve around. Orbital velocity is the velocity with which body revolve around other bodies. A circular in circular orbital satellite in circle CIRCULA circular orbital or BIEL orbit. In circular orbit, a satellite has a satellite satellites. A satellite has a constant magnitude. A satellite in circular orbit, a satellite has a constant magnitude. In circular orbit, a satellite has a constant magnitude magnitude. In circular orbit, a satellite has a constant magnitude with constant magnitude of tangential velocity for orbital. In circular orbit, a satellite has a magnitude of tangential velocity 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 CALLAD called orbital velocity ORBITAL orbital velocity VELOCITY velocity. In circular orbit satellite has a magnitude of tangential velocity called orbital velocity. A satellite has a tangential and orbital. All day you fucking enjoy. Now, here's the price. 2, 3, 3. Relax. 4. Not bad. Yo, you're fucked. 5. I'm fucked. Orbital velocity is the velocity with which body revolves around other body. In circular orbit, a satellite has a constant magnitude of tangent velocity called orbital velocity. Consider in circular orbit, a satellite has a constant magnitude of tangent velocity called orbital velocity. Consider a satellite of a mass m. A satellite of a mass ms revolving with a velocity v. ms is revolving revolve with velocity velocity v o in circular orbit of a radius in CIRCULA circular orbit with a radius with radius around 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 the earth, around the mass, the masses, around the mass, around the earth, of mass me एक पेज का नंबर. Consider a satellite of a mass m is revolved with a velocity v(o) in a circular orbit of a radius r around the earth of a mass me. Orbital velocity is the velocity in which a body revolves around the other body, which a body revolves around the other body. Orbital velocity is the velocity in which body revolves around other body. Orbital velocity is the velocity in which body revolves around other bodies, in which body revolves around other body in circle. And orbital velocity in circular orbit, a satellite has a constant magnitude of tangential velocity called orbital velocity. In circular orbit, a satellite has a constant magnitude of tangential velocity called orbital velocity. Tangential velocity called orbital velocity. In orbital velocity is a velocity with a satellite. Velocity in orbital velocity is a velocity in which a body revolves around other velocity. In body revolve around other body. In orbital velocity is a velocity with which body revolve around other bodies. In circular orbit, a satellite has a constant magnitude of a tangent velocity called orbital velocity. Consider a satellite of a mass ms. Consider revolve with a velocity v of a radius r around the mass of mass me. Gravitation force of earth provide a centripetal force. I don't give a fuck. Centripetal force, gravitation force provide gravitational force provide provide centripetal provide gravitation force of earth provide gravitation force of earth provide centripetal force. The centripetal force to satellite centripetal force to satellite satellite. Centripetal force of satellite, centripetal force on satellite. This party started. measuring the volume. MEASURE, measure the volume. The volume of a small vernier caliper, small spherical, SPHERICA, spherical object, OBJECT object, using screw gauge, SCREWGAUG gauge, and calculate again. Diagram बनाना है साथ में. Alright, let's make it. Yo, we can make this like this, and we can put like this again. Okay. Okay, now with this we have to have 3, 4, 5. Okay. Okay. Alright. And we make it go. Okay, let's make it be somewhere. WIREPIECE, please, wire please. Red, medial, SPIN, spindle, any wire piece, needle, ठीक है, spinel, okay. ये sleeve हो गया, SLEVE, sleeve, WEVE sleeve. diam datum 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 line linear linear scale 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 linear rectangular circle I don't know Campbell ratchet volume of sphere volume of a surface W is equal 4 by 3 multiplied by pi radian cube the distance cube whatever radian or distance cube 1 by 6 multiplied by pi d cube diameter total total measurement MEASURE measured diameter D is equal MSR plus CSR multiply by least count plus 0 error plus minus 0. Three. 1, 2, 3, 4, 3, 4, 5, 6, 7. Like I'll just EG ले लो E.G example बड़ी चीज़ है 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 19, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay. What is main skill reading? What is main SCAL skill? READING reading 7.MM reading 7.0 7.0. What is circular? Circular. What is CIRCUS? Circular reading 23. Total reading moment. Total reading measurement 7.23 mm. ठीक है, अब कैलकुलेट करते हैं. formula D is equal M S R main scale reading plus circular scale reading multiply by least count plus minus zero error 0 ERROR. जीरो एरर है नहीं तो इसलिए हम लिखेंगे नहीं. अच्छा इसमें ERO proof is equal D is equal main scale reading 7 plus 23 multiply by 0.1 mm is equal to 7.23 mm. ये पहले लिखा. Step calculate in Word. Calculate in volume, V is equal 1/6 multiplied by pi d3. D is equal 7.23. 2 4 ले लें, 2 3 ले लें, 2 4 ले लें, 2 4 4 4 4 4 2 4 3 okay. V is equal 1/6 multiplied by pi 7.243 cube. Let's calculate this bastard. Okay, 1/6. Fuck. Okay. Go. Multiplied by 7.243. Yep. V is equal 198.95 9546 and step 4 mean derivation. Mean derivation division delta D. Okay, equal delta D division oh fuck me, I did not know the fucking equal 0.01 and delta D is equal to 0.0 ये तो लिखने की जरूरत नहीं है। 0.1 and 0.01 plus 0.01 is equal to 0.0253 is equal to 0.0067 mm. You got to be shitting me and be freaking answer. Get out. Alright, fuck this shit. Bullshit.